We are live with the next day of our netcode challenge. So let's start the next day. Start with the next task. Easy task. So I suppose that it should be done quickly. So you are given two strings. Merge the strings by adding letters in alternating order, starting with word 1. If a string is longer than the other, append the additional letter onto the end of the merged string. Return the merged string. Okay, so what does it mean alternating order? So we need do A, then P, then B, then R, then C, right? A, P, B, Q, C, R. Okay. So first this one, then this one, and then we actually add in, and we're starting from word 1. All right. So let's think about, so here we definitely see that we need to do it in m plus n time. And with space, I believe we need to create another string, right? We need to create another string. So space would be also n plus n. With approaches, first approach, I see that we have 2 pointers. So we have 2 pointers, I and j, and I it would be pointer for string s, and j for string 2. So, for example, we have one string and another string. We have pointer here and pointer here, and let's say that another string is less. So what we do, we first add this one, then add this one, then we move 2 pointers, then we add this one and this one, then we move 2 pointers. We see that this pointer is more, so we don't add, and here we still add. So we need 2 pointer with 2 if blocks, so it should be quite simple. So we have string builder. Then we need 2 pointers. And here we need while I is less than word 1 length, and or j, and j is length than word 2 length. Then we do some operations. So let's first check this logic. So when I becomes equal to word length, then we go out. So we definitely need here or. And when both of them false, then we go out. So not and, but or. And here we do the following. So if I is less than word 1 length, we append to our string word I char at I plus plus, right? And here we have another if. So it's about j. And here we'll just return our sp2 string. So pretty much simple one. So let's start. And let's submit. Yep, so we're done. Let's check how we done it previously. Yeah, so actually the same. The same here, only we see that we have only one I, but I think with J it's much more understandable of what actually we are doing. It's interesting, like what submission, it's actually the same, so just some there and here optimizations. So this one we finished. Let's go to the next one. Merge sorted array. So we are given two integer arrays sorted in non-descending order, and two integers m and n represents the number of elements in nums1 and nums2. We should merge into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length m plus n, where the first m elements denotate the elements that should be merged, and the last n elements are set to 0. Right. So we have two arrays that we need to merge into one array. So how it's actually we are doing this? So we just we also have two pointers to two arrays, and when we finished, like we cannot finish the second, like and when we finish with, for example, array 2, right? We cannot finish with array 2, I believe, because we need to swap here. So what do I mean? So let's imagine we have such use case, right? So here it's like 4, 5, 7, and then we have 3 zeros, and here we have 1, 2, 3, and we need to merge this array. So first we check if this value is greater than this value. We just swap these two elements here, and then we move and we have two pointers, and we move our pointer here, and here we just stay with this pointer. So now again we swap with 5, and then again we move, but here it's not correct, right? So it's not actually correct. So it's not correct, right? So how we can merge? What if we will first, for example, go and swap with all elements that we have here to make this one the least, and then we just put here. So for example, we swap 1, 2, 3, and then we just put them there. But what if we have here, for example, 1, and here we have 4, and here, for example, we have 7, 1, here we have 2, 3, and 4. So we put 7. Okay. Yeah, so the problem with this swapping here that when we swap 4, we actually lose our logic, right? Because yes, we swap this 4, but we cannot swap this 4. We cannot put into this this element. We should put it somewhere here, and it can be like situation like this. So we should put it here. So what if we will start from the end, and we have like 3 pointers here, not from the start but from the end, and put elements here. So for example, here we put 8, then we move this pointer, we put 7, we put 7, and then we move this pointer, then we put 5, and then we move this pointer, then we put 2, then 4, then 1. Sorry. And 4, and 2, and 1. Yeah, I think that's actually the logic. So we should start from the, not from the start, but from the end. So let's say that we have some I where we put all our elements, and we start from nums length -1. And also we have, we already have M and N. So M, it's positions where we should start, right? And we should do like this while M is greater or equal to 0, or N is greater or equal to 0. We do this loop, and and here we do like this. So so if M is less than 0, maybe like this, like while M is less than 0 and N is greater or equal to 0, we so we populate all our elements with nums 1 I minus. We populate with, so N with nums 2 N minus. And I think here we should do like this. So N is less, M is greater, and here we do the following. Here we should do like this, because we should start with indexes, not with lengths. And here it should be both equal and now we are checking both elements. So nums 1 M is greater than nums 2 N, else So if nums1 is greater, then we put into nums1 I minus minus, we put nums1 m minus minus. Otherwise, we put nums1. Yeah, we also always should put nums1. Here nums2, yes. Nums1 minus minus, we put nums2 n minus minus. Yeah, and then it should work. So let's just run it and check. Accept and submit. Yes, we're done with 100%. Let's verify how it was done last time. Yes, we see that it was done quite more complicated because we use here OR operator, and I think with AND it's more easier. Yes, so the same here. Yeah, so here it's more, like I think more easier. Here also like more easier. We even have something that we done a long time ago. Right, so we solve this question. We do not have editors, but yeah, I think from implementation point of view, it's pretty understandable how we done it. So let's mark it as done, and let's go to the next one. Okay, so we are given an integer array nums, sorted in non-decreasing order, remove the duplicates in place, such that each unique element appears only once. The relative order of the elements should be kept in the same. Consider the number of unique elements in nums to be k. After remove duplicate, returns the number of unique elements k. The first k elements of nums should contain the unique number of sorted order. There are many elements beyond k minus 1 can be ignored. So the judge will test your solution with the following code. So we have nums and expected nums, the expected answer with correct lengths. So remove duplicate now calls your implementation until k. Okay. So for example, we have here 1 and 1, so we should return only 2 elements, and yeah, and all others will be skipped here. So here as well, like, and we see that they already sorted, right? So we need to have kind of yeah, let's see, cleansing. So we need to solve this algorithm. Yeah, we can actually use hash map here. It's understandable, and then just put all elements in hash map and just return how many elements we put. Hash set even. If we will take a look at our nums, so it's not too big. So we but it's already sorted. So I'm thinking we can have like two indexes, right? One index will go to the right, and this one will stay. Yeah, so we can move 0 here. Can we use additional data structure here? If all selected paths, then your solution will be accepted. Yeah, so with additional data structure, we can just start 0, and then okay, so how can we do this? So definitely we need maybe to create let me think. So we have numbers. So we can create a map with counting. So or it can be actually not map. It can be like a set here, but currently we are on 2 pointers, right? So we definitely sum 2 pointers. So I believe like this it should be, maybe like this. Let's just draw an example. Let's just take this this example here. Let's take 2 pointers, right? So we have these 2 pointers, and when we meet with I think when we meet with this element, let's see how we can implement. So when we meet element this one, so 0, so we can move and do it here. Then we find here another one. We can put it here. Then we go to the next one. We put it here. Yeah, so I think something like this. So let's have 0 and current element, so it will be current nums 5, and here like 4 we start with j is equal to 1, j is nums length, and j++, and if nums j is not equal to nums I, what we do, we put under nums I plus 1, we put nums j, right? Then we can do like this, we increment I by 1, then we put here nums j, and current modify to nums j. And we should return I. Let's run. Okay, so how it works, so we have 1, then 1, ims nums j is not equal to nums 1, so here's the equal. Then when they on 2, they are not equal, they increment I by 1, or maybe it should be like this. Then, yep, submit. Okay, and we are done. So let's check what we have here. Yeah, so the same, like we have result. Yeah, looks like the same. Here we have set. Why doing the set? Oops, here we don't have set. Here we also have set. Yeah. This one is pretty close to our implementation. So we also done with this one. So let's stop sharing, and that's all for today.